Hi, today we're going to talk about geometric sequences. This is a thick packet, yeah it is, but take comfort in knowing that there's a lot of space in here for you to think and work things out. There's cartoons and drawings, and we're going to get through most of this together. So let's put your name on it to get it started so we know it's yours. And even here on the front page, we have really important information. This is our explicit formula. A count n is equal to a sub 1 times r to the n minus 1. I know it's crazy, but we're going to take care of it. Don't worry. The recursive formula is also very important for today, where a sub 1 is your first term, and we have a count n, or a sub n, is equal to r times a to the n minus 1. So n is the step that you are on. Or is in question. Sometimes you're going to be asked in a problem, it'll say, this is the pattern of behavior. Great. What would the result be the 47th time that we do this pattern of behavior? And the purpose of this lesson is to say, well, I really don't want to do the pattern 47 times. I have other stuff to do today. Yeah. So if I can use these equations to help me jump all the way straight to the 47th step or the 47th time to get that value, great. That is the point of these equations, okay? So let's turn the page real quick. And just knowing that tiny little bit, I want you to just do the before column before we do any more discussion than what I've just told you. Looking at the equations that we've just looked at, try and do this column. No, I'm not going to hurt you. I just want to see where your brain is. And we'll talk about it in a little bit. So pause the video and see what you can make a healthy, educated guess on from what we've already discussed. All right, so now we're going to get started trying to figure out what these things are. We'll go back to that little pre-quiz in a few minutes. We are asked if this sequence is geometric. If it is, state the common ratio of the explicit formula. All right, so you've got a lot of vocabulary here that we don't even know what it is, and I'm going to help you get there, so don't panic. All right, so a common ratio is, do we change the same amount one to another by building a ratio of the previous two values? So let's see. We'll look at these two values. What is 27 divided by 9? And you would say 3. I say great. And then we do it again, only with these two values. What is 81 divided by 27? And you pull out your calculator and you do it, and you'd say, oh, look at that, it's 3. I'd say great. And then we do it again. And I would say, what is the ratio of these two values? 243 and 81. And again, you turn on your calculator and you would divide it And you would find, yep, it's still 3. So the answer to our first question, is this a geometric sequence? That's a yes. It is. Good job. Well, how do you know that? My common ratio, 27 divided by 9, is 3. That is my common ratio. Ta-da! And my common ratio is given to us as the letter what? It's on your front page. R. This is R for ratio. All right, so now we're getting some understanding. My common ratio, that's R, is going to be my values divided side by side. My consecutive values, do they have the same result whenever I divide them? All right, so the explicit formula, if you go back to your front page, the explicit formula is this one. So we'll write that down. A sub n, the step that we are on, is equal to A sub 1, that's the first step, times R, the common ratio, to the n minus 1 power. Okay. So our formula is, hey, tell me an equation so that if I want to find any spot along this sequence so that I can just get there and not have to do the step, do the step, do the step. Don't think about that as a dance. That's weird. Then we can drop in our numbers to go find that location, that place. So this is the wondered about step for down the road. A sub 1 is the first value that they told me, which is 9. So that's this guy. One is for the first one that they told me, times R, my ratio, to the n minus 1 power. And that's it. I could use this little formula to tell me anywhere down the road if I wanted the 7th step or the 57th step. I would put the 57 in right here for the little n, and I get an answer when I type this into the calculator, and that would tell me it. Okay? So now this is your turn. Don't be nervous. Same process. I want you to stop the video and you're going to find the geometric sequence, first term, the ratio, but this time make sure that you recognize you're looking for the recursive formula. So make sure you use the right formula, like that one. Pause the video. All right, next page, example 1. This sequence of 4, 8, 16, and 32, it is geometric. Ta-da, they told us so. We need to state the common ratio, the explicit formula, and find the 6th term. We have 3 things to do. All right, well, let's start at the beginning. The common ratio. So since I know that this is geometric, I only have to do it once. I'll use those 2 numbers. So 8 divided by 4, and what is that? 2. So 2 equals R. Great. Now it's asking for the explicit formula, but in order to have an explicit formula, I need to know what a sub 1 is. My first term is a sub 1. All right? So now my explicit we remember is a sub n, the nth step. That is equal to my first term, which happens to be 4, times my ratio, which is r of 2 to the power of n minus 1. Got it, done. That wasn't so bad. So now let's go do the 6th term. So the way to write this would be, hey, according to this on the 6th step, according to this sequence on the 6th step, I would have 4 times 2 to the 6 minus 1. And you know what 6 minus 1 is. You've got that. So let's go type this into the calculator and get a value. All right. So here on my calculator, four parentheses, 2, close parentheses, caret 5. Enter 128. So on the 6th step, the 6th term, I would get 128 if I keep doing this pattern of behavior. That's not so bad. That's pretty easy, yeah? I hope so. Let's do example 2 together. So we're going to state the common ratio and the recursive formula for the sequence. All right? So we know what the common ratio is. We already found that. So let's rewrite that. It's the same sequence as listed above. And we'll rewrite it just in case you're wondering of where is this coming from. Same one as above. So now the recursive formula, I again need to remember a sub 1. There's a sub 1. So the recursive formula is an acknowledgement of, hey, a sub 1 is that. So you have to announce. That's what it is. We've announced it. And then you just say, so if I'm going to use that, I would put in my R, which is 2, times the previous step, a sub n minus 1. And that's it. I mean, there's not really a lot to do. There's just not. So if you weren't sure, remember you can always look at the very front and you just put it there. And we announced it, and then we said if I needed to use it, I could. There it is. So this would be like the 6th step, 2 times the 5th step. That's what that's saying. Okay? All right, so you turn the page. And those are already there. So the kind person who made this handout for you, they accidentally put this page answers in there. Oh well, they were nice. Let's go look at the next page. So, geometric sequence with a little bit of extra practice. Alrighty. So, practice number 1. The sequence is 1, 6, 36, 216. Great. And it is geometric. Good. State the common ratio, the explicit formula, and the fifth term. So hopefully this is starting to click. Pretty nice. So let's do that. To get any of this started, you always need an a sub 1. What is a sub 1? Yeah, it's 1. It's that guy right there. I need a common ratio. So that'll be these two values, or any of the two values. What's 6 divided by 1? 6. So the explicit, which means I can tell you right there, that's what it's going to be. That's what explicit means. It's very detailed. So the explicit formula says if you want a detail of that step, then you're going to have the initial value times my ratio to the n minus 1 power. That can get you the detailed step information. So this is asking about the fifth step. Let's go get it. So a sub 5, the fifth step, is equal to 1 times 6 to the 5 minus 1. So what is 5 minus 1? Yeah, it's 4. So that means this is 1 times 6 to the 4th power. Let's pull out your calculator so we can check. 1 parentheses 6 close parentheses caret 4. Wow, 1,296. So the fifth term in this sequence is 1,296. Nice job. All right. Let's do practice number 2 together. Okay. So here's a sequence. We know it is geometric. They told us we need to state the recursive formula. Okay. So to do that, I know that I need a sub 1, which is 1. I know that I need the common ratio, which I still have the same values. So that's still 6 for R. And then the recursive formula is really simple. I know it seems strange. So for the recursive, you say the initial value was what it was. And then you say, so A sub n will be your ratio, that was 6, times the previous step, whatever that was, A sub n minus 1. So if we looked for the fifth step here, it would be 6 times whatever it was for the fourth step. That's what it is. All right, I want you to stop the video, and I want you to try to do practice 3 and number 4 on your own. So if you need a little help, let me know. All right, let's talk about Sasha and Arnold. They're trying to find the recursive formula, the common ratio, the explicit formula for the sequence below. of -3, -12, -48, and -192. And their answers are listed here. So we want to find out, is either of them all the way right? And then we got to figure out what to do, how to do. Okay. So looking at this, let's do it ourselves first. Let's do it up here. So we know a sub 1 really has to be what? Yeah, -3. We know the common ratio, -12 divided by -3 is 4. That's R. Okay. So we know that a sub n for the explicit will be your initial value times your ratio to the n-1 power. We know that exp. We know that the recursive will be a sub n, where the ratio was 4 times the previous value of a sub n-1. That's what it should be. Let's go check out Sasha's work. What did she do right? Her common ratio, that's good. Her explicit formula, that's good. Her recursive, whoa, what happened on a recursive? The initial value is good, but the recursive is messed up. So let's write that down. Oh, I didn't even spell her name right. Sorry, Sasha. Let's check out Arnold. Arnold had his common ratio. He had, whoa, what's going on in his explicit? But his recursive looks pretty good. So Arnold had his -3 and 4 reversed for the explicit. Not bad. Okay, your job to finish is this last page. It's your ticket out the door to finish this. And I want you to go back, and now that we've done all of this, whoa, sorry. I want you to check and maybe change some of your answers on your quiz. So this is what I need you to finish. So check and change where you need to. And also do your last page. Sorry, technical difficulties. All right, let me know if you need some help.